Hi everybody, this is Alexis Sanchez from Eurecat, and this is a short presentation of the Real-Time Anomaly Detector for the Work Package 5 on the Stop IT project. In this video, we will be explaining what AirTag is, showing one use case for the tool and a short walkthrough. The AirTag is a robust artificial intelligence-based software tool, specialized in the industrial control system environments. It controls both the physical and logical layer of the environment, collecting information about traffic, final data values, and events. It is also a substitute for the classical rule-based CMs. The final goal of AirTag is to be able to detect malicious actions as well as malicious behavior, with combined physical and logical layer. To this end, the AirTag consists of a system for detecting known logical attacks and anomalies in the behavior of data transmitted by the ICS applications, amongst, among other types of infrastructure information. It is also a short and long-term data storage and a backup manager. Now, in order to better understand the tool, I will explain a use case for the AirTag. In this use case, more tools developed on the Stop IT project will be involved. This is Eurecat testbed, consisting of a script simulating a water tank, a SCADA LTS simulating the SCADA system controlling a real human-machine interface, and an Schneider PLC. On top of that, our own tools have been installed and are used as information sources for the AirTag. On this scenario, we will be developing the exposed use case shown in this presentation. We are making some assumptions in order to set up this use case. First, human presence detector is located on the same physical location as the water tank is, being a restricted area, so no one except the maintenance staff should ever enter. Second, we have already registered our own tools, devices, and PLC in the real-time anomaly detector. Lastly, we have had enough data from human presence detector to make a model for normal and expected visits for maintenance staff to the restricted area. Okay, let's see the adversary behavior. First, he physically enters the room by stealing maintenance staff keys. Then, he connects to the network with its own machine. Later, he scans the network and discovers HPD, the human presence detector. Once he knows about HPD, he reboots the tool via terminal command. Meanwhile, HPD is rebooting, he performs a man-in-the-middle attack in the ICS network to overflow the water tank, and it succeeds. Lastly, he erases the failure register in our database in order to minimize his footprint. And then he leaves the place and returns maintenance keys with no one noticing it. Okay, let's see what happens in our system while the adversary is doing the mentioned actions. The HPD is sending beacons messages until it detects a presence, and almost immediately it reboots. The detections has been for a short period of time, so it is not enough to raise an alert. Nevertheless, taking out that this information is stored in AirTag. When the adversary enters the network with its own machine, the AirTag detects the new host, reunites all the information available, and stores it. The information is then classified as anomalous via a CM rule, and AirTag raises an alert. Here, you can see the graphical interface where the alert will be shown. Next step is the network scan, which AirTag detects and saves information about it. If we have enough data, we could correlate with previous IP being the same, and we could increase information available in previous raised alert. When HPD is rebooted, it sends an event to AirTag. Following the reboot, it detects the adversary presence while it tries to do the man-in-the-middle attack. Even before the man-in-the-middle attack is detected, an alert is raised because an anomaly in the physical space. Here you can see the three types of messages that the HPD is sending to the AirTag and the AirTag is storing. The man in the middle is detected now and adds information to AirTag tool. Although non-artificial intelligence techniques are used for this detection, it is used to get information from the adversary that will be available for further processing with artificial intelligence. Finally, database modifications are not detected when performed, but it will be detected when someone tries to retrieve the tampered value, with RSDP tool sending an alert to AirTag, and AirTag enriching this alert and forwarding it as needed with the previous information, so the user knows that the retrieved value has been tampered. Now, I will show you the different graphical unit interfaces that AirTag tool has. Here, we have Ambari controlling the whole cluster of AirTag. So we are able to know the health of every component of AirTag. In this interface, we can see all the sources ingested by AirTag right now. Although these are running, we can configure even more, like for example, whatever source that is using JSON map or syslog or the protocol like leaf. AirTag also uses Kibana, so beautiful dashboards as this one can be done. This information is being enriched in real time, so geolocation-based IP is possible, and we can draw this kind of maps. Statistical, statistical distribution can be visualized as this flow duration chart. Another possibility is to reflect the latest alerts in Metron, like it can be seen here. You can group them from source, like this one, snort, or you can group it by any other means, like for example, by host. Last possibility shown in this video will be the specific information from network, like web request or DNS request. Closing this quick walkthrough, I will show you the interface from Metron alerts. As you can see, we have here the interface previously shown on the PowerPoint, and you can escalate, open, resolve, or dismiss any alert. Apart from these alerts, you can group them like here by source time or like here by IP source address, and you can configure these columns. Thank you for viewing this video. That will be all.